everyone, we're going to evaluate the given integral, and we're using trigonometric substitution to help us evaluate. So here's our problem again. Should have written it down. So it's the integral 1 minus sine of x divided by cosine of x dx. So let's split this up. This is really 1 divided by cosine minus sine x divided by cosine x dx. So that gives us the integral of, this is going to be secant x minus tan of x dx. All right, and I can split this up as the integral of secant of x dx minus the integral of tan of x dx. So now let's evaluate, and we have secant of x dx here. So that's going to be ln absolute value of secant x plus tan x minus, now let's look at tan of x. That one is right there. So tan x dx equals ln of secant, absolute value of secant x. So I'm going to write it again, and then we'd put plus c here. So let's going to clean this up because we have logs. So again, we have ln secant x plus tan x minus ln of secant x plus c. Now, forgetting about the c now, since I have this minus, that means I can combine this into a single log. So that's going to be ln absolute value of secant x plus tan x divided by secant x plus c. Of course, secant x is just 1 over cosine x. So what I can do again is just write this as secant x plus tan x. Instead of having the denominator, move this up and write this as cosine x. All right, and then absolute value plus c. All right, now if you distribute this cosine here, or we could have actually just divided here, but if you distribute, you're going to get secant x times cosine x plus tan x times cosine x. Now that simplifies to, this equals 1, because this is 1 over cosine. So that's just going to be 1 plus, and this is just going to be sine. And we can change this to parentheses instead of absolute value, because 1 plus sine of x is greater than or equal to 0. So we don't have to put absolute value here. And again, this is sine of x, because this is sine x divided by cosine of x times cosine x, and those two would cancel. And that's it. Thank you. Have a nice day. Bye-bye.